You're spending $150 per year on pest sprays and replacement plants while creating the exact conditions that invite pest invasions for free. And this is not an accident. This is the result of a gardening system that deliberately taught you to grow monocultures, because monocultures require constant intervention and products. And constant intervention creates permanent customers. Meanwhile, I haven't lost a single plant to pests in 3 years. 0 sprays, 0 losses. The difference isn't effort or better products, it's design. You built a pest buffet. I built an ecosystem where pests can't establish. Here is what most people miss. Pests do not attack healthy ecosystems. They attack weak, isolated plants in monocultures. Think about it. When is the last time you saw aphids destroy a wild forest edge or a thriving meadow? You have not. Because diverse plant communities confuse pests, harbor predators, and grow plants with strong cellular immunity. But your garden? Rows of identical tomatoes, a block of cabbage, pure lettuce. You built a pest buffet with a neon sign that says, "Easy target, no defenses, come feast." And this is not an accident. Modern gardening deliberately separated plants from each other because monocultures look clean and make seed companies rich. But here is the reality. Monocultures are biological deserts that require constant intervention. Sprays, replacements, research, money. Meanwhile, indigenous farmers grew food for centuries without losing crops to pests, without a single spray bottle, without midnight Googling sessions about organic pest control. The difference was not effort, it was observation. They watched what thrived together. They built relationships between plants, and those relationships prevented pest problems before they started. Here's what that looks like. The Three Sisters system. Corn, beans, and squash planted together in one bed. This is not about aesthetics. This is about function. The corn grows tall and provides structure. The beans climb the corn stalks and fix nitrogen from the air into the soil, feeding all 3 plants. The squash spreads across the ground as living mulch, shading out weeds, retaining moisture, and creating a prickly barrier that deters pests. And here's where it gets interesting. Pests that specialize in corn cannot establish, because the beans and squash confuse their search patterns. Pests that target squash get distracted by the corn and beans. The diversity creates a biological maze that breaks pest life cycles. This system worked for thousands of years across the Americas. No pesticides, no fertilizer inputs, no weekly battles. The plants defended each other through relationships. And when colonizers arrived and forced monoculture agriculture, pest problems exploded. Because monocultures remove the confusion. A field of pure corn is a pest highway with perfect signage. A block of cabbage is an aphid paradise. You removed the relationships that prevented invasion. Now here is what this actually means for your yard. Companion planting is the modern term for what indigenous farmers practice through observation. You are not just putting plants next to each other randomly, you are building functional relationships. Tomatoes planted with basil and marigolds. The basil masks the tomato scent that attracts hornworms. The marigolds repel aphids and whiteflies with their root exudates. The tomatoes provide shade that keeps basil from bolting. 3 plants, multiple pest defenses, 0 sprays. Carrots with onions. Carrot flies locate their host by scent. Onions mask that scent completely. Meanwhile, carrot foliage confuses onion pests. You are creating what ecologists call confusant planting. The pests literally cannot find their target plants because the scent signals are scrambled by companion diversity. Brassicas with nasturtiums. Here is a different mechanism, trap cropping. Nasturtiums are aphid magnets. They attract every aphid in the area away from your cabbage and kale. The aphids infest the nasturtiums instead. And because nasturtiums are vigorous and pest-tolerant, they handle the aphid load without dying. You sacrificed one plant to protect 10 others. This is design, not intervention. But here is what separates this from the companion planting charts you have seen that do not work. You need density and diversity together. One basil plant next to one tomato does almost nothing. 10 basil plants interplanted with 8 tomato plants and a border of marigolds creates a functional ecosystem. The pest confusion requires abundance. The scent masking requires volume. This is not decoration. This is ecological engineering. And the diversity does something else most people do not talk about. It creates habitat for predators. When you plant flowers between your vegetables, you are not just making things pretty. You are providing nectar and pollen for parasitic wasps, lacewings, hoverflies, and predatory beetles. These insects need flower resources for part of their life cycle. Then they hunt aphids, caterpillars, and pest larvae in your vegetable beds. You built a predator army without buying a single beneficial insect package. Here is the core principle that changes everything. Diversity prevents pests from establishing. Monocultures invite them. And every spray you use to fight pests in a monoculture kills the predators that would have controlled those pests in a diverse system. So you create a cycle where you need more sprays next season because you eliminated your natural pest control. The chemical companies knew this. They built customer dependence into the system. Indigenous observation broke that cycle. They watched forests, meadows, and wild edges where pests never dominated. They copied those patterns into their gardens. Polycultures, companion relationships, predator habitat, living mulch. And the result was food production that sustained communities for generations, without external inputs, without pest catastrophes, without the exhausting intervention cycle you are trapped in now. You are not failing because you are doing it wrong. You are failing because you are gardening in a system designed to require constant intervention and continuous purchases. Break the system. Build relationships between plants. Create diversity that confuses pests and harbors predators. This is observation-based ecology, not product-based warfare. And it works because it is how ecosystems have defended themselves for millions of years. Here's what this looks like in specific combinations. Tomatoes, basil, and marigolds together. Plant 8 tomato plants with 20 basil plants scattered between them and a marigold border. The basil releases aromatic compounds that mask tomato scent signals. Hornworm moths use scent to locate host plants. When they cannot detect tomatoes through the basil barrier, they move on. And the marigolds produce thiopenes in their roots that repel soil nematodes and above-ground aphids. You are creating chemical defenses without buying a single spray. Squash with nasturtiums around the perimeter. Squash vine borers devastate monoculture squash plantings. But nasturtiums attract beneficial parasitic wasps that lay eggs and borer larvae. The wasps need nectar. You provide it. They hunt borers in exchange. And meanwhile, the nasturtiums act as a trap crop for aphids and flea beetles, drawing them away from your squash. You sacrificed a few nasturtium plants to protect your entire squash harvest. Brassicas with aromatic herbs. Plant cabbage, kale, and broccoli with thyme, sage, and oregano throughout the bed. Cabbage moths locate brassicas by scent. The herbs create olfactory chaos. The moths cannot pinpoint their targets. And here is the bonus. The herbs are perennial. Once established, they return every year, providing permanent pest confusion with zero replanting effort. But here is where it gets interesting. Companion planting is the surface layer. The real pest immunity starts underground in the soil. Think about it. When pests attack a plant, they are literally piercing or chewing through cell walls to access sap and tissue. Plants with thick, strong cell walls and high silica content are physically harder to damage. Plants with balanced nutrient profiles and robust immune responses produce compounds that make them taste terrible to pests or trigger defense mechanisms when attacked. This is biological immunity, not chemical intervention. And where does that immunity come from? Mycorrhizal fungi networks in the soil. These fungal threads colonize plant roots and extend meters into the surrounding soil, accessing water and nutrients the plant roots cannot reach. In exchange, the plant provides sugars to the fungi. This partnership increases nutrient uptake by 400 to 800%. And plants with mycorrhizal connections grow stronger, faster, and more resistant to every stress, including pest attacks. Beneficial bacteria in the soil break down organic matter and make nutrients plant available. They also produce compounds that trigger systemic resistance in plants, essentially vaccinating them against pest and disease pressure. And when you build soil biology through compost, mulch, and diverse plantings, you are not just feeding plants, you are building their immune systems. Here's the mechanism most people miss. Plants grown in biologically active soil have higher nutrient density. Higher calcium strengthens cell walls. Higher silica makes tissues tougher. Balanced micronutrients enable plants to produce defensive compounds when threatened. And pests preferentially attack weak, nutrient-deficient plants because they are easier to penetrate and digest. Healthy soil grows plants pests cannot easily destroy. Now here is what happened when I switched to this system 3 years ago. I stopped spraying completely. I interplanted every bed with companions. I added compost and mulch to build soil biology. And I have not lost a single plant to pests since. Not one tomato to hornworms. Not one cabbage to aphids. Not one squash to borers. The pests show up, look around, get confused by the diversity, find the plants too tough to damage, and leave. Here is what that means economically. I was spending roughly $120 per year on organic pest sprays. Neem oil, insecticidal soap, BT for caterpillars, gone. I was replacing $30 to $50 worth of destroyed plants every season. Tomatoes, cabbage, squash that pests demolished, gone. And I was spending 4 to 6 hours per week on pest management. Spraying, researching, hand-picking, replanting. That is 200 plus hours per year. Now I spend maybe 30 minutes per season planting companions and observing what thrives. The time return alone is staggering, but the harvest improvement is even better. When plants are not stressed by pest damage, they produce more. My tomato yields doubled, my brassica harvests tripled. Because the plants put energy into fruit and leaf production instead of healing from constant pest attacks. And this is not new knowledge. Before industrial agriculture, every successful garden and farm used diversity and soil biology for pest resistance. English cottage gardens were famous for interplanting flowers, herbs, and vegetables in dense polycultures. They rarely had pest catastrophes because the diversity prevented establishment. And American indigenous farms used three sisters and dozens of other companion systems for millennia. They built soil fertility through observation and plant relationships, not purchased inputs. The chemical agriculture model broke that system deliberately. Monocultures require sprays. Sprays kill soil biology. Dead soil grows weak plants. Weak plants need more sprays. The cycle creates customer dependence. You can break it by designing gardens that work with ecological principles instead of fighting them. Healthy soil grows plants pests cannot destroy. Diversity prevents pest establishment. An observation teaches you what relationships work in your specific microclimate and conditions. This is the system that indigenous farmers perfected and modern gardening abandoned. So how do you actually start building this system? It is simpler than you think. You do not need to redesign your entire garden overnight. Start with one bed this season. Pick 3 companion combinations and observe what happens. Here is combination 1. Tomatoes, basil, and marigolds. Plant 4 to 6 tomato plants in one bed. Scatter 15 to 20 basil plants between them, not in rows but interplanted randomly throughout. Border the entire bed with marigolds. That is it. You created confusant planting, scent masking, and beneficial insect habitat in one 4x8 bed. And now you watch what happens over the season. Notice which pests show up and which do not. This is observation-based learning. Here is combination 2. Carrots and onions. Alternate rows or scatter them together. 3 parts carrots to 1 part onions works well. The onion scent masks carrot flies completely, and the carrot foliage confuses onion pests. You are building relationships that defend both plants without effort. Here is combination 3. Any brassica with nasturtiums and herbs. Plant kale, cabbage, or broccoli with nasturtiums as a trap crop border and thyme or oregano scattered throughout. The herbs create scent confusion. The nasturtiums draw aphids away. You are designing pest resistance into the bed before a single seed germinates. But here is the key. Density matters. Do not space plants according to seed packet instructions that assume monocultures need maximum airflow to prevent disease. In polycultures, you want density because that is what creates the pest confusion effect. Plant closer. Fill gaps with herbs and flowers. Make the bed complex enough that pests cannot navigate it efficiently. And if you only have containers on a balcony or patio, this works at any scale. One large container can hold 2 tomato plants, 6 basil plants, and 3 marigolds. A window box can grow lettuce interplanted with chives and nasturtiums. And even a 12-inch pot can support a pepper plant with basil and a single marigold. The principles do not change. Diversity confuses pests regardless of container size. Living in an HOA that bans vegetable gardens? Plant ornamental edibles. Kale looks like decorative foliage. Rainbow chard is prettier than most flowers. Scarlet runner beans on a trellis look like an ornamental vine. Intermix them with flowers and herbs, and nobody recognizes them as food production. You are creating a disguised polyculture that follows HOA rules while producing harvests. Small yard? Use vertical space. Pole beans on trellises. Cucumbers on A-frames. Tomatoes caged and staked. And then interplant the ground level below them with lettuce, herbs, and flowers. You are stacking layers of diversity in the same footprint, maximizing pest confusion per square foot. Now here is the long-term strategy. Observe and adapt season by season. What you plant this year teaches you what works in your specific microclimate, soil, and pest pressure. Maybe basil and tomatoes thrive together in your yard, but marigolds struggle. Fine, replace marigolds with nasturtiums or zinnias next season. The ecosystem teaches you through results, not through generic companion planting charts. Keep notes, simple observations. Which combinations produced well? Which pests showed up? Which beneficial insects you noticed? Which plants looked healthiest? In over 2 to 3 seasons, you build a knowledge base specific to your garden that no book or chart can provide. This is observation-based ecology in practice. And here is where seed saving connects to pest resistance. When you save seeds from your healthiest, most pest-resistant plants, you are selecting for genetics that thrive in your exact conditions. And over generations, you breed local adaptation into your garden. Your tomatoes become more resistant to your specific pest pressures. Your brassicas develop immunity to local aphid populations. You are creating a garden that evolves stronger defenses every season. Add compost and mulch continuously. Every time you harvest a plant, chop it and drop it in place, or add it to your compost pile. This feeds soil biology, which feeds plant immunity. And the more organic matter you return to the soil, the stronger your mycorrhizal networks become. The more beneficial bacteria colonize, the more robust your plants grow. Soil health and pest resistance are the same thing viewed from different angles. Think about it. You are not spraying anymore. You are not researching organic pest solutions. You are not replanting destroyed crops. You are spending 5 minutes planting companions and then observing what thrives. The system defends itself because you designed relationships that prevent pest establishment. This is what true self-sufficient gardening looks like. Not fighting harder. Not buying more products. Building an ecosystem where pests cannot dominate because diversity confuses them. Predators hunt them, and healthy soil grows plants too strong to easily damage. You can stop the pest warfare cycle right now. Stop spending weekends in battle mode. Stop throwing money at sprays that kill your soil biology and create dependency. Start designing polycultures that defend themselves through plant relationships and soil immunity. Indigenous farmers proved this system works over thousands of years. I proved it works in a modern backyard over 3 years with 0 pest losses. And you can copy this system starting with your next planting season. Observe what thrives. Build diversity. Feed your soil. Let the ecosystem teach you. And watch pest problems disappear because you removed the monoculture conditions that invited them in the first place.